Hello everyone, this video is about the topic of multiplying and dividing the algebraic fractions. So far I have recorded 4 videos about simplifying the algebraic fractions. So they are gonna help a lot while doing this concept of multiplying and dividing algebraic fractions. So please watch those videos before you come to this one. Now, so as we know, I am showing you a very simple example. Let's say we have one algebraic fraction as a over b. It can be as complicated as possible. For example, a can be a quadratic expression, let's say x squared minus x minus 2. B can be something like x squared minus 4. So it is possible. Okay, and it can be as simple as just a over b as well. So whenever you have two algebraic expressions like a over b and it is in multiplication with the second algebraic fractions which is c over d, so we can write the numerator parts together with the multiplication sign. So a will be multiplied by c, so it is a times c, the whole numerator, and the second one is the denominator. You can multiply the denominators together and you can form a complete denominator as b times d. Now this is a whole process which we are going to follow to multiply the two algebraic fractions. After that we should have to simplify the fraction. When we multiply, some of the factors will be cancelled out. We can factorize the expressions, the numerator and denominator, and then we can cancel some of the fractions in numerator and denominator. Then comes the question of dividing the algebraic fractions. So what is the basic concept behind it? Again, we have the first fraction a over b. Then we know when we divide the arithmetic fractions, for example, we have 1 over 2 divided by 3 over 4. So what we do, we keep the first fraction as it is. We change this sign into the multiplication sign and we take the reciprocal of the second fraction, or you can say reverse. So it will be 4 over 3. So this is converted into multiplication, and same thing works for the algebraic fraction. So I have the first fraction as it is a over b. Then I change this sign of multiplication to division sign will be changed to multiplication, and then I will take the reciprocal of the second fraction. And after that, because we have multiplication now, so a will be multiplied with d. The whole thing will be divided by b times c. Now let's understand this concept with the help of some questions. Here I have given some practice questions for all of you to try, and similar questions I'm gonna explain. So first two questions in the practice one are quite easy. If you see this question and this one, it has just one term like a squared 2 4 2a, and same here, but here you need to factorize. In fourth question also you need to factorize. So let's try these questions now. Now for example, the first question is b squared over 3a times by 6a squared over 4b cubed. So the first thing, because it's a multiplication, I will be writing them all together. So b squared times 6a squared over 3a times 4b cubed. Now if you people know the index laws, you can apply the index laws. Which index laws you can apply? Like a to the power of m divided by a to the power of n, this is equals to a to the power of m minus n. It will work here. And if you are not aware of those things, so you can watch the videos on index laws, or you can do it in another way. B square means b times b. This method which I am right now I am doing, like b times b, it is good if you have the small powers like 2 3. But if it is having 15 16 powers, then it's difficult to expand it, and then better to apply the index laws. So we have b times b times 6 and 6 times a squared, which is a times a, then divided by 3 times a times 4 times b times b times b. B cubed means you have to multiply b 3 times, like b times b means b will appear 3 times in multiplication. This is the best way to say. So now b and b will be cancelled, another b's will be cancelled, a will be cancelled. Here we have 6 and here we have 3 times 4, which is 12. So I can write it like 6a over 12b. And now 6 and 12 can be cancelled out because it is equivalent to half. So this is half of a divided by b. You can write it like this. You can write it like a over 2b. They both are same. Okay. So this part and this part. Or you can write a half and then a over b. This is also fine. You can answer in any form. They all are equivalent. They all are same. Okay, next question is, we have c squared divided by 3c over 9. Now see here, we are talking about algebraic fractions, and this is given in the form of a fraction, numerator upon denominator. But here it is just c square. Always remember, whenever there is a whole number, like in arithmetic, if we have a whole number 2, 3, 9, 4, we can write it as a fraction by writing it as 2 over 1. You can make it as a fraction, a whole number as a fraction, by giving the denominator a value of 1, because if you divide anything by 1, it remains the same. So here c square, same thing follows in the algebraic expressions. So c square divided by 1, and then because this is a division, so we do multiplication here. We will change the sign, and also we will take the reciprocal of 3c by 9, second fraction. Now it is c times 9 and divided by 1 times 3 times c. So c's will be cancelled out. 3 ones are 3 and 3 times 3 is 9. So basically our answer is 3c over 1. But now because we are giving our final answer, so you can just write 3c, because divide by 1, even if you write or don't, it's same thing. When you do calculations, when you start calculations, you have to write. When you are giving your final answer, no need to write. Okay. Now the next question is, this is our next question. T minus 5 over t square plus t, and that times by 4t plus 4 over 3t minus 50. So first thing, because it's a multiplication, so t times 5 times 4t plus 4, that is the first thing. One denominator and one numerator and one denominator. Now here it is not simple a times b over c square something, but here we have the expressions. First expression, this is t minus 5, is the most simplified. But if you see 4t plus 4, in 4t plus 4, I can see 4 is common. So I can make it simple as 4t minus 5 times 4 times t plus 1. Here what sign is given? It is always a multiplication. Okay. Divided by t square plus t. Now see, t square plus t, can you factorize? The basic thing is, when you write them in as a single numerator and denominator, after that you have to see each expression. If you can factorize it, so always do the factorization. That is the only way to simplify it. So t square plus t, I can write as t times t plus 1. So t times t plus 1. Again, I am not writing here multiplication. By default, it is a multiplication sign, because we are writing as factors. Like for example, 6, it is 3 times 2. For arithmetic numbers, we have to write. But for algebraic expressions, we can write just AC or A times C. We prefer to write this way, but its meaning is this. Okay. And then we have 3t minus 15. So 3 can be taken as common. T minus 5. Now you can see some of the factors are common, present in numerator and denominator both, like t minus 5, t minus 5, t plus 1, t plus 1. So when we cancelled out them, we are left with only 4 in the numerator, and these are all like in multiplication by this is 1, this is 1, this is 1, this is 1. So 4 times 1 is 4, and it's divided by this one is t, and here is 3. So the answer is 4 over 3t. Now the next question is, in this question we have the division part. So in the division part, what you need to do is same concept. First we convert this division into multiplication. So the first step would be m squared minus 4m over 10m minus 2 multiply by, take the reciprocal, 3m plus 12 over m squared minus 16. And then the next step will be m squared minus 4m times by 3m plus 12. I am writing as a single numerator and single denominator, 10m minus 2 times m squared minus 16. Now because if you see here, you can see that we can simplify these expressions. So what I do, I write m squared minus 4m. You can do it separately also, just to make sure that there will be no mistake. So m squared minus m is m multiplied by m minus 4. Then we have 3m plus 12, which can be written as 3 times m plus 4. Then we have 10m minus 2, which is 2 times 5m minus 1. And the last is m squared minus 16. It is a very special kind of factorization. This is known as difference of the square of two numbers. Difference of the square of two numbers. So this is m squared minus 4 squared, and this is equals to m minus 4 times m plus 4. This is the rule, a squared minus b squared. The both numbers should be represented as squared numbers. If they are not, like here it was given 4, so I have to represent it first as like 4 square. If it was 25 here, then I will say 5 square. So this is equals to a minus b times a plus b. You can write it any order. You can write it like a plus b times a minus b also. Now we know all these factors, like all these expressions in the factored form. So now we can write them again in the numerator and denominator with this form. So we have, the first thing is m square minus 4m, which is m times m minus 4, multiply by 3m plus 12, which is 3 times m plus 4. And then this is divided by 10m minus 2, which is 2 times 5m minus 1, and times by m square minus 16, which is m minus 4 times m plus 4. You can see m minus 4 got cancelled, m plus 4 got cancelled. So we are left with m times 3, which is 3m, divided by 2 times 5m minus 1. Now because we are giving the final answer and there is no more further simplification, so you can just multiply the denominators because it's 2 times something. So we can multiply, so it will be 10m minus 2. We got the same thing. We factorize it just to make sure, in case if we get a factor like 5m minus 1, but we did not get it, but that's okay, you can rewrite it. So this was all about the multiplication of the fractions, algebraic fractions, and division of the fractions. The next video will be on the topic of adding and subtracting the algebraic fractions. That will be the last topic in the algebraic fractions, because we have already done simplification. Today we have done multiplication and division, and the next will be addition and subtraction. Thank you.